today's lecture, we will be discussing about economic benefits of cloud computing. Now, whether to migrate to cloud or build your own infrastructure, this choice is heavily dependent upon the cost factor. There are other benefits of cloud computing due to which the user might migrate to cloud, but economic benefits are the major drivers which made cloud computing a success. So let us see the economic benefits of cloud computing. The main drivers of cloud computing are economy of scale and simplicity of software delivery in its operation. In economics, economies of scale means increasing in productivity or decreasing in average cost of production that arises from increasing all the factors of production in the same proportion. The conventional wisdom regarding the economies of scale in cloud is that larger the cloud provider is, lower is the average cost of production, translating into enormous enterprises over do-it-yourself approaches, that is having the infrastructure on the premises. And then the simplicity with which the services are delivered is also one of the major driving factors. To obtain the services on cloud, users require a web-enabled device and a good internet connectivity. So let us see, cloud computing allows reducing the capital cost associated to IT infrastructure, because once the service are being obtained from cloud, the users need not install any IT infrastructure on their premises, which not only saves the capital expenditure cost, it also saves the space on the infrastructure. It saves the powering cooling cost of the servers or data center which would have been set up on the premises, and it also saves the management cost. Next is eliminating the depreciation or lifetime cost associated with IT capital assets. So once the infrastructure has been purchased by the user, over time it will depreciate. Maybe it will require provisioning over a period of time. Let's say every 5 years, the IT infrastructure will have to be provisioned so that it can handle the growing demand of the user. So these factors, this factor is also very important while considering whether to set up the infrastructure on the campus or to migrate to cloud. Then third point is replacing the software license with subscriptions, cutting the maintenance and administrative cost of IT resources. So if the user chooses to take the services from the cloud, they don't have to bother about the software version or the licensing of the software or upgrading the software. Everything is done by the cloud provider. So the cost can be classified into direct cost and indirect cost. So let us first look at what is direct cost. So the biggest benefit of cloud is financial. So they say that the major reason why most of the users opted for cloud was the economic reason. It offers pay as you go model. So in this model, the amount of resource, the users will be charged based on the amount of resources consumed by them. So this motivated a lot of users to migrate to cloud, because cloud could then handle along with the elasticity feature which the cloud offers, it could handle the demand of the user, the decrease in demand or as well as the peak in demand with time. So it eliminates or reduces capital cost. Cost occurred in purchasing an asset is useful in production of goods or rendering of service. So capital cost is the cost which is defined as the cost of purchasing an asset or in production of goods or rendering of service. So if you see the budget which is spent on IT infrastructure and software, it constitutes a significant expense for the enterprises. Enterprises is that is the industries or the firms or any user, even a single user. So, owning a small or medium-sized data center introduces several operational costs in terms of maintenance, electricity, and cooling. In fact, electricity and cooling, that is this power requirement, is one of the major costs of installing the data center. So that is, it is not just that the capital expenditure capex is high when the data center is installed on the premises. Even the operational expenditure, that is opex, is pretty high. Additional operational costs are incurred in maintaining an IT department with an IT support system. So apart from the powering of these servers and data center, IT personnel are also required to maintain and support that data center. Other costs are triggered by purchase of potentially expensive software. So to summarize, the user will have to incur the cost due to the infrastructure, due to the maintenance of that infrastructure, uh, due to the IT support personals which the user will have to recruit to support that infrastructure, and the cost of the software. So what does cloud computing do? Cloud computing shifts the capital cost into the operational cost, inducted by renting the infrastructure and paying subscription for the use of software. So now the cost, the capital cost which the user had to pay upfront in purchasing the infrastructure and maintaining that is now shifted into operational cost, because instead of now purchasing the infrastructure, the user will rent the infrastructure. Instead of buying the software, the user can pay for the subscription of the software, and this renting and subscription of the software is charged as per use. So the billing model can also be per hour model for users. So they only pay for the amount of time they use those resources. Therefore, these costs can be controlled according to the needs of the user. If the user needs to use more resources on a particular day, he'll be charged more. Or if the user needs to use less resources on some other day due to the less demand, the user will be charged accordingly. Cloud computing also introduces reduction in administrative and maintenance cost, because now the administrative and maintenance tasks have to be done by the cloud provider, because the cloud provider, they set up a data center, and maintenance of the servers and cooling, powering of these servers, these servers which are housed in a big data center, it is all the responsibility of the cloud provider. Next is that depreciation cost disappears. So if the user decides to migrate to cloud, there is no depreciation in the cost. But as the IT needs of the user will be served by the cloud, then there is no IT capital asset that depreciates over time, which is with the user. So user does not incur any cost due to the depreciation factor. Lastly, cloud computing, especially infrastructure as a service-based solution, they help manage unplanned capital costs generated by short-term needs. These costs can be turned into operational costs that last as long as there is a need for them. So let us say that an organization has 30 systems, and then for 1 week they need 5 more systems with a particularly high configuration. So they don't have those systems, so now they have two options. What they can do is they can either purchase 5 high configuration systems, or what can they do is they can rent these systems, that is they can opt for infrastructure as a base service, and they can rent these service from the cloud. So then after 1 week, once their need is over, these resources can be returned back to the cloud. So this unplanned capital cost, there was a sudden demand of 5 systems, maybe because somebody was visiting or some important project came which had to be done in parallel with the project which was going on in their organization. So they needed 5 systems for some reason. Now, this was an unplanned capital cost. This would have been an unplanned capital cost, but due to cloud, it turned into operational cost. And then after 1 week, since the resources were returned, it was given back to the cloud. The users were charged for only 1 week. That is, the operational cost lasted as long as there was a need for them. Let us look at what is indirect cost. Cloud computing eliminates some of the indirect costs that are generated by IT assets. For example, software licensing and support. So users they use the software applications on a subscription basis. Thus, there is no need for a licensing fees. So if I want to use some software, I'll have to purchase that software at least for a month. But in case I have to use that software for, let us say, there is just a single task which I have to do in that software. So what I can do is I can simply take the help of cloud computing, and I can use the software which is provided by the cloud provider, and I'll be charged on per hour basis for the amount of time I use the service. Another important aspect of this is, which has also a very huge environmental impact, is that the carbon footprint emission reduces. So now what happened was that if users migrate to cloud, then instead of if every user had their own infrastructure on their premises, everybody needs to take care of the cooling, and it is a huge cost in terms of power consumption. On the contrary, if the users they do not set up their own infrastructure, they take the services from the data center, then there are these huge data centers which nowadays are completely green. In fact, in last couple of years, Facebook has whatever data centers Facebook has set up, they are all green data centers. By green data centers we mean that these data centers are powered by green energy, which is clean energy, that is renewable energy, that is either solar energy or wind energy. Because green energy is intermittent in nature, these data centers will definitely be always backed up by the traditional grid energy, which is also called as brown energy. But in any case, data center consolidation has definitely resulted in a smaller carbon footprint. In terms of pricing models which have been introduced by cloud computing, we can distinguish them into 3 different strategies. So first is tiered pricing. So in this model, cloud services are offered in several tiers, each of which offers a fixed computing specification and service level agreement at a specific price per unit of time. So in this, what happens that the cloud provider will fix the services in tiered model, that it says tier 1, this is the amount of resources you will get, this much computing power, this much storage, and this is the pricing for that. This is the second tier, this much amount of computing power, this much amount of storage, and other things which are required by the user, and this is the pricing for that. So this is called as a tiered model. So what do cloud service do? Cloud providers do? They have fitted the cloud service in such a tiered model, and they have fixed the pricing for this, and the pricing is per unit time. So this model is used by Amazon for pricing the EC2 service, which makes available different server configurations in terms of computing capacity, that is CPU type, speed, memory, and they have different costs per hour. So now the user, as per their requirement, as per their demand, and as per their QoS requirements, they can choose the tier and the corresponding pricing for that particular tier to avail the services. The second pricing model is per unit pricing model. So this model is suitable where the principal source of revenue for cloud provider is determined in terms of units of specific service, such as data transfer and memory allocation. So for example, this model is used by GoGrid, which makes customers pay according to RAM per hour unit for the servers deployed in GoGrid cloud. So that means if a user wants to increase the RAM of their devices, they can take that service from GoGrid, and they will only pay for the amount of time they have used that. So they pay according to the RAM per hour unit. Third model is subscription based pricing. This model is mostly used by software as a service providers, in which users will pay a periodic subscription fee for use of a software or specific component services that are integrated in their applications. This periodic subscription fee for the software will be much lower compared to the purchasing of the software by the user. So all these costs are based on pay as you go model, which basically provides a more flexible solution for supporting the delivery on demand of IT services. So this is what actually makes possible the conversion of IT capital cost into operational cost. Since buying the hardware cost turns into cost for leasing it, and cost generated by purchasing of software turns into a subscription fee paid for using it. Let us look at 5 economic characteristics of cloud computing. So the first characteristics is the common infrastructure. So in cloud computing, the resources are pooled and they are dynamically shared infrastructure. So this is a very important characteristics which lead to the economic benefit, because now the resources, there is a pool of resources. So, and the objective of the cloud provider is to use these resources efficiently to maximize their profit, while ensuring that the quality of service guarantees promised to the user are maintained. Second characteristic is location independence. So ubiquitous and responsive service, the cloud computing provides service, ubiquitous service. That means it can provide service everywhere, and it is responsive, it is very fast. So the services which are provided to the users so users can be anywhere in the world, they can utilize these services anytime and anywhere. So it enhances the user experience and convenience. This is because that now with just a web enabled device and internet facility available, the users can avail the services from anywhere and anytime, irrespective of whichever cloud provider or from whichever location that service is being offered. Next is dispersion also enhances the availability. Now this says that the data centers, they are dispersed all over the globe. They are not at a particular physical location. Geographically, there are data centers in every nook and corner of the world from where the service is being offered to the user. Now this dispersion also enhances the availability of the services, because now if there was a single centralized data center which is providing service to the user, then if that data center goes down due to some reason, due to whatever reason, then the service to the user will be disrupted. But in case that there are so many data centers, if user is taking service from one of the data centers, and let us say that data center goes down due to a disaster or due to some failure, then the virtual machines, they can be migrated to some other data centers, and through live migration, and the user will experience uninterrupted service. So dispersion also enhances the availability. I would also like to add a point here. Dispersion not only enhances availability, it also enhances the reliability. So what is reliability? See, if the data of the user is stored in a data center at a particular location, maybe on their own premises, let's say, and if somehow that data center fails, uh, then what will happen is they lose their data. But if the data is stored in the cloud, then the cloud provider just does not store the data in one of the data centers. It will also store or replicate the user data in one of the other data center, which is in geographically a different location. Usually it is said that they should not be in the same disaster zone. So what is a disaster zone? That is, so if you see that the world is divided into disaster zones, every country. So it says disaster zone is a zone which, if affected by a disaster, so then that whole particular zone will be affected. So when the cloud provider is setting up the data center, it ensures that data centers, if it sets up one data center in one location, preferably the other data center which it stores, which it sets up, is in some other location which is in a different disaster zone. So that if, let us say, due to earthquake or due to some other disaster, if this particular one data center is affected, at least the other one should be there for the backup. Next point is online accessibility. So without networks, there is no cloud. So key enabler as services are accessed over network. So this is an obvious requirement for cloud computing. So for cloud computing, users should have a web-enabled device and a high-speed internet connection preferably. Next point is utility pricing. That means creating value and with usage sensitive pricing. Thus, the charges for the resources are all exactly aligned. So this means that, so utility pricing means that the users, when they use the service, they will be charged as they are, consuming some utility. They'll be charged based on the consumption. The last economic character say is that it is an on-demand resource. So this is due to the elasticity property of cloud computing. So that is right quantity of the right resource available exactly and only when needed. So this is a major driver behind the economic success of cloud computing. That is, the cloud is able to provide the right quantity of right resource exactly and only when needed by the user. So what do we mean by right quantity and right resource? By right quantity, we mean that the resource should be able to satisfy the user's demand, and that demand is not static in nature. It is variable in nature. Sometimes the user will require more resources, and sometimes they will demand for less resources. So whatever is the demand of the user, that should be provided whenever the user demands it. So all these characteristics in some way or the other led to we call them economic characteristics because they led to the economic success of cloud computing. Is cloud less expensive? Now this is the question which every potential user would like to pose to the cloud provider. Laurie McVitie, she is a principal technical evangelist at F5. Evangelists are those whose role is to educate and promote a particular technology. So she he very famously said that it is cloud computing and it is not cheap computing. That means the cost benefit is unique to each customer. So cloud computing cannot be sold by saying that it is cheaper. There are other many benefits like availability, reliability, security, which also come along with cloud. That is, there are other reasons due to which people move to cloud rather than just the cost. So it is possible that the cloud delivers resources and services at a lower unit cost than an enterprise. That means enterprise means it means to say that on-premises services. So it might be possible that cloud computing service, it is cheaper to take services from cloud computing rather than an on-premises service. Also, it is also possible that cloud costs more than unit cost basis. It might be possible that it is costlier compared to on-premises solution. So, how do we define unit cost? Unit cost is the cost for server hours or gigabyte months. So, depends for how much time the server has been used, or it can also be as like for how many months the storage has been used for. So basically, it says that cloud computing, it can be either costlier compared to the on-premises solution or cheaper than the on-premises solution. It is very, very unique to the profile of the customer. It depends on their demand and their utilization. Now, whether to use cloud or not. Now, this can only be decided by comparing two factors. Those two factors are what is the cost of the cloud and what is the cost of the dedicated resource which will be owned by the user. So it calls for characterization of unit cost of an on-demand per pay-per-use cloud resource relative to unit cost of dedicated resource. So these two costs need to be quantified. That is, what is the cost of taking that service on demand on a pay-per-use basis from the cloud relative to what is the cost of owning dedicated resources for obtaining that service. So when we talk about the dedicated resources, there are a couple of points which should be kept in mind while calculating unit cost of dedicated resource. So dedicated resource may be owned and may incur a cost of depreciation which should be taken into account. The dedicated resource may be leased and may incur a monthly fee. So either this, or it can be, this also has to be taken into account. Or it might be possible that the user has taken loan from the bank, so that is the dedicated resources is financed. So and the cost is then not just the principal, but it is also interest fee to the bank. So all these points, either of these, whichever is applicable to the user, should be used for quantifying unit cost of a dedicated resource. We'll discuss a very simple model, cost model, to decide whether the user should opt for cloud or should opt for on-premises services, that is setting up their, buying and owning their own infrastructure. So we define a term called utility premium. So utility premium U, it is the ratio of cloud unit cost to the baseline unit cost. So this C here is cloud unit cost, B is the baseline or owned unit cost. So U is the ratio of C to B. If U is equal to 1, that means the cloud cost same as ownership. If U is less than 1, then the cloud will be cheaper. So if we see here, U may vary over time, but it is assumed to be constant in this framework. What are the reasons that it may vary over time? The cloud provider charges may vary because it depends on the, it also depends on some factors like the cost of power, which may vary. Then there is depreciation cost, the cost of owning the units, they vary over time. So this factor is variable with time. It's not a constant factor. But in this framework, we'll assume that this is constant. Next point is that the demand of the user is not static. It is not constant demand. It is a variable demand. Even over a period of 24 hours, over a day, if you see the demand for the resources, maybe the networking resources, let us take an example, vary over 24 hours. For example, if we see here that if we assume that this is a 24-hour scale, over a longer period of duration, it will definitely vary. But even during the day, it might be possible that in the mornings or in the nights, the demand is low, and during the peak working hours, the demand is very high. So the point is that the user's demand is a variable demand, which has a peak value and an average value. So peak of this demand dt is peak demand, is denoted by P. And the average of dt over a time period 0 to t is this A. So the peak demand and the average demand have been marked here. Now an important point is that because the demand is variable, when the user wants to set up the infrastructure on premises, then what should be the capacity of the infrastructure? Should it be this, that it should be able to cater to peak demand? But if the user sets up the infrastructure to cater to demand of this level, then most of the time, that is for this time and this time, it will be underutilized. That means the infrastructure is being utilized over a very small period of time, fully utilized, and this would lead to loss to the user. So then let us say that the user sets up the infrastructure to serve the average demand, that is at this point, but then in this point there will be certain time for which that infrastructure will not be able to support the demand. However, such a variable demand is easily supported by cloud computing due to its property of elasticity, that is increasing the resources allocated to a particular user or decreasing it as per the demand of the user. So let us go ahead and calculate the cost of cloud cost and the baseline cost, and we'll do it for a period of time t from 0 to t. So cloud cost so cloud cost is denoted by CT. So this is a product of U, B, and the demand over the variable demand integrated over a period of 0 to t. So this integrated over a period of 0 to t will be the average demand A into t. So this will be U, B, A, T. This is a product of these four terms. Whereas on the other hand, the baseline cost for time t can be expressed as B, which is the baseline cost, into T into P, that is the peak demand. Now on comparing these equations, if we compare these two equations, we find that cloud will be economically beneficial only when CT is less than BT. That means this term should be less than this term. So on comparing equation 2 and 3, we find that other terms cancel, and the cloud will be beneficial only if U is less than P by A. What does it mean? Utility premium is less than the ratio of peak demand to the average demand. Now in this, peak demand will obviously is always greater than the average demand. So P will always be greater than A. So this factor will always be greater than 1. It will be equal to 1 when the traffic is a constant traffic. If it is a constant rate traffic, then P will be equal to A and this will be equal to 1. But otherwise, P will always be greater than A. So now it is an interplay of the demand of the user, the variability of the demand of the user, and the utility premium, which decides that whether the cloud is economically beneficial or not. If U is less than 1, then cloud is always a good idea, because we know that P by A, the smallest value of P by A is 1. It cannot be less than 1. So in that case, if U is less than 1, then irrespective of the demand profile, cloud will always be economically beneficial. Next is, if the cloud costs the same as the baseline cost, that is U is equal to 1, then the relative cost depends on whether the demand is flat. If demand is flat, then there is no benefit from pay per use go policy. So it will cost the same. But if A is less than P, that is, there is some peaks and then there is some average demand, and there is a difference between this, then pay per use go policy may give some benefit to the user. If U is greater than 1, then definitely cloud will be more expensive compared to owning the infrastructure on a unit cost basis, because that means C is greater than B. But then in that case, if A is equal to P, that is, demand is flat, it is a constant rate demand, then owning resources would be less expensive, definitely. But if A is less than P, that is, if the demand is spikier compared to the utility premium, then cloud can still be cheaper. So in this framework, it is an interplay of 4 factors which decide whether migrating to cloud is economically beneficial or not. And these factors are CT, that is the unit cost of cloud, BT, baseline unit cost, third is the average demand, fourth is the peak demand. Average and peak demand are specific to every user. Therefore, deciding whether migrating to cloud is cheaper or not is unique to every user, as it depends on their demand profile. So to summarize, in this lecture, we discussed the economic benefits of cloud computing. We saw the costs, direct cost and indirect cost, and then we saw 3 pricing models. Then we went on to discuss the economic characteristics of cloud computing, and we saw a model for a framework for utility pricing. Thank you.